Hello guys, welcome to this YouTube channel. I would like you to subscribe to this YouTube channel and hit the notification bell to get updated each time we post a video. Alright, today we'll be looking at a proof that you should prove that beta m comma n is equal to 2 over integral from 0 to pi all over 2 of sine 2m minus 1 theta, this is theta here, multiplying cos square n minus 1 theta, the theta. So we should prove that this is equal to this. Alright, from our formula of beta, we know beta function, beta, that is m comma n, to be equal to the integral from 0 to 1, integral from 0 to 1 of what? Integral from 0 to 1 of x raised to the power of n minus 1 into bracket 1 minus x raised to the power of n minus 1 dx. This is what we know our beta function to be. So now in this beta function, let's call this equation 1. So what we are going to do here is we are going to substitute sine square theta in equation 1. Substitute sine square theta in equation 1. So if we do that, we are going to have beta m comma n to be equal to, so this is still integral from 0 to 1, substituting our x to be equal to sine square theta. We are going to be having sine square, so you know this is going to be 2 into the bracket of n minus 1, then you have theta into 1 minus sine square, this sine square theta, bracket close of n minus 1. So now, okay, we know x, we are putting x to be equal to sine square theta. So if we differentiate sine square theta, we are going to have the x to be equal to 2 sine theta cos theta the theta. This is what we are going to have to differentiate this, 2 sine theta cos theta the theta. So we are going to, instead of putting the x here, we are going to put 2 sine theta cos theta the theta. This is the theta here, the theta. So this is what we have. So let's look at this now. In our trigonometry, you discover that you have sine square theta plus cos square theta to be equal to 1. So that means cos square theta is equal to 1 minus sine square theta. So that means we are going to substitute this value of 1 minus sine square theta with cos square theta. So this will become integral from 0 to 1 of sine square. Now we can open this bracket, of course. We are going to have, we are going to have 2m minus 2 theta. Then instead of having this, we are going to substitute our value of this. So we are going to have cos the power of 2. So that 2 is going to multiply this. You have 2n minus 2 theta. So we are now going to put this, which is multiplying 2 sine theta cos theta the theta. So this is what we have. Now we are going to simplify this further. So this can also be written as integral from 0 to 1 of, you can rewrite this as sine raised to the power of 2m theta divided by sine raised to the power of 2 theta. This is actually the same thing with this. So you can write this as this, multiplying cos to raised to the power of n theta all over cos raised to the power of 2 theta. Now all of this will multiply 2 sine theta cos theta d theta. So this sine will cancel one of the sine here, and this cos will cancel one of the cos here. So what you'll be having remaining will be integral from 0 to 1 of sine square. Now discover that you have just one sine here because these two have been cancelled. So you are going to have 2m minus 1 theta. Then it's multiplying this. Now you also have just one cos here. Then this is going to be equal to cos 2n minus 1 theta. That one will come up. This one sine here will also come up. So you have 2 remaining here, so you can put these 2 outside here. Then you have the theta. So this is what we have. Now we are going to change our limit from 0 to 1. So using x to be equal to sine square theta, x to be equal to sine square theta, you will discover that when you substitute the value of theta to be 1, x equal to sine 1. Sorry, when you substitute the value of theta to be 0, the lower limit 0, what we are going to have here is 0. And when you substitute the value of theta, x to be equal to sine 1, now the inverse of this is the same thing as pi all over 2. That's why now this is going to now be equal to, this is beta m comma n will be equal to 2 integral from 0 to pi all over 2. So let me write that. This is pi all over 2. Then from here now we are now going to have sine 2n minus 1 theta cos 2n minus 1 theta d theta. So this is our answer, and this is the proof. We have to prove that this is equal to this, and this is the proof. So thank you very much for staying on to the end. Please subscribe to this YouTube channel and hit the notification bell to get updated each time we upload a video. Thank you.